Hello, time for next problem, and this one will be different than the previous ones. For once we will work with a product of a number of factors, not with a sum of a number of terms. Let's start. Derivation of a formula, problem number 6. And here is this terrible formula. So you see that here we also work with just any natural positive number n, and we have to prove this formula. You see we have a product of n factors, and each factor is expressed in this way with a number k. So k goes from 1 to n. This large letter pi stands for product. So this tells you that you have to multiply these things. First one is for k equal to 1 will be 1 minus 4 divided by, if k is equal to 1, then you have 2 minus 1 is 1, so it will be indeed this number here. Then for k equal to 2, you will get here 4 minus 1 is 3, 3 squared, 9, and so on and so on. And the last one will be for k equal to n, so you simply plug in k equal to n here and you get this factor. And we have to prove that this product is equal to this number, which depends on n, obviously, but you see that this formula will hold for all the values of n. And again, also this problem is coming from this course, Mathematics Proofs by Induction, where I proved this by induction, of course, how else. And then in this course I just gave you a PDF with the solution. And this is how it looks. So again, if you want to work with proofs by induction, you can register for this free course about proofs by induction. And again, in order to prove something by induction, we really need to know the answer. And in the derivation which I will present now, you don't really need to know this in advance, but it's kind of nice to know this in advance, because then you know if your computations were correct. But again, we would manage without this answer here, because I will just show you the derivation. So this first number, I will simply write minus 3, because it is minus 3, right? 1 minus 4, it is minus 3. So I just leave it like it is. But then, in all the others, I will do something special. First, you see that here I have 2 squared divided by 3 squared. And you may wonder why I want to write it down as squares. And the answer will be that I want to apply this formula for the difference of 2 squares again. So I want to have squares. And even more, here I have to subtract this fraction from 1. And you know that in order to subtract fractions, I need a common denominator. So I will write down 1 as 3 squared divided by 3 squared. It is maybe strange, but later it will show quite advantages. So here I write 3 squared divided by 3 squared minus 2 squared divided by 3 squared. It is this second parenthesis. And I do the same in the next ones. But in the next one I have a denominator 5 squared. So I write here 5 squared divided by 5 squared, like this. And the next one, 7 squared divided by 7 squared, 2 squared divided by 7 squared. And so on and so on. And now maybe I will write down the last but one, which is not visible here. But you know that it will be 1 minus 4 divided by. And now I need the previous odd number squared. And what is the previous odd number before 2n minus 1? It will be 2n minus 3, right? Because 2n minus 2 is the even number just before this odd number. So the previous odd number is 2n minus 3. So this will give me here 2n minus 3 all squared divided by 2n minus 3 all squared minus 2 squared divided by 2n minus 3 all squared. And the very last one is here, 2n minus 1 all squared, 2n minus 1 all squared. This is just a fancy way of writing down 1. And here 2 squared divided by 2n minus 1 all squared. Now I'm done with my preparation, and now I will simply perform this subtraction of fractions in each parenthesis, and I do have a common denominator already everywhere. And I will at the same time apply the formula that a squared minus b squared, you know, the difference of two squares, that it is equal to a minus b times a plus b. So I will apply this formula in each parenthesis. So see what's happening here. I start by copying this minus 3 because, well, nothing happened with this one. And here, in this one here, the first one, I get 3 squared in the denominator, and in the numerator, I get 3 squared minus 2 squared, and I apply this formula here with a equal to 3 and b equal to 2. A minus b is equal to 1. And a plus b is equal to 5, right? Because 3 minus 2 is 1 and 3 plus 2 is 5. Then the next one. What is the next one? 5 squared in the denominator. And in the numerator, I get 5 squared minus 2 squared. And again, the same formula with a equal to 5 and b equal to 2. A minus b is equal to 5 minus 2, it is 3. And a plus b is 5 plus 2 is 7. Okay, then I continue the next one, 7 squared, and again, 7 squared minus 2 squared is equal to 7 minus 2, it is 5, times 7 plus 2 is 9. Now I will take another pen, another color, and I will write down the next one, which is not visible here. But you know that in the next one, in the denominator, we would have 9 squared, because it must be the next odd number squared. And here you see we have 1, 3, 5. The next one will be 7 times what? Well, it will be 9 plus 2, right? So it must be 11. So you see also that here maybe another color and another color for this 11 here. Here will be 11. We have 5, 7, 9, 11. So you see that it's so you see that we have odd numbers as factors, and they are just arranged in different ways. So here I will write 3 dots, just symbolizing that it continues in the same way. And now I proceed to the last but one. So what do I have in the denominator? I will have 2n minus 3 all squared. And again, in the numerator, I apply this formula for the difference of two squares, this time with a equal to 2n minus 3 and b equal to 2. So the difference will be 2n minus 3 minus 2 is minus 5, and the sum will be 2n minus 1. So you see that the numbers which are in numerators always differ by 4, right? 1 times 5, 3 times 7, 5 times 9, always the difference of 4 between the factors. And the very last one will be 2n minus 1 all squared. And in the numerator, first the difference of 2n minus 1 and 2 is 2n minus 3, and then the sum will be 2n minus 1 plus 2 is plus 1. And now we look at this. And we see that we will have a lot of cancellations. You see, here I have 3 squared in the denominator, and in numerators I have 3 and 3. So all cancels out. Then I have here 5 squared in the denominator and 5 and 5 in numerators. The next one, maybe not blue, maybe this one. Here I have 7 squared, 7, 7. And you see that everything will disappear in this way. So what's happening at the end? At the end you see that this will disappear with this and with one which was one step before, but we didn't see it. Now 2n minus 5 will also disappear with some factors which will come before. So this one will disappear, but now we have to be careful. Why? Well, because we have a 2n minus 1 here and 2n minus 1 all squared here. And there is, well, nothing more here, which would cancel out this entire square of 2n minus 1. So this means that the only thing we can do here with this last factor is cancel this one with the square. You see? Because only one 2n minus 1 will get cancelled, not the second one. Okay, so altogether, what is left here from this entire product, what is not cancelled is this minus sign, this one, 2n minus 1, and 2n plus 1. So this is the only thing what is left from this entire large product. So factor 1 doesn't change anything, so I don't have to write it down, but the minus sign is important. And here I will have in the numerator 2n plus 1, and in the denominator 2n minus 1. And I see here it looks pretty similar like this one. What do I have to do in order to make it look identical? Well, in the numerator I can change order of the terms. It doesn't change anything, right? And this minus sign before this entire fraction I can incorporate in the denominator, and then I will get minus 2n plus 1 in the denominator, which I can write as 1 minus 2n, which is exactly the result I was expected to get. And that's all I wanted to show you in this video. Thank you for watching. Bye bye.